Okay, welcome back to the shop and part 4 of the lightning strike diagnosis on the 2005 Ford Escape. Now, if you're just joining us, this is a 4-part series, as the title would suggest. And just to sum it up, in the first 2 videos, we did a full diagnosis coming out as a mobile call, and we had to figure out why the vehicle would not start even with a new PCM the customer had installed. So we went through the whole diagnosis and found that the fuel rail pressure sensor was biased. Therefore, the vehicle was running way too rich and would actually start, run horrible, and then die out. Once we got that disconnected, the vehicle went into failure management effects mode, and I was able to drive the vehicle back to the shop here and finish diagnosis and fully condemn the fuel rail pressure sensor. We did that in the last video, part 3 there, and then I replaced the fuel rail pressure sensor, and now the vehicle, of course, has no drivability issues. It runs absolutely great, but we still have the ABS module not responding. Now, usually this wouldn't be a big deal. I don't need ABS, many people say. But in this case, on this particular vehicle, the way it's set up, with it being down and not responding to any of the other modules on the network, we lost the speedometer, the odometer, which is weird, and we also lost 4x4, because the 4x4 module is always waiting for wheel speed information to work. And then, of course, we don't have ABS. So it's definitely a concern because it's the speedometer and the odometer mainly. So we're going to go after diagnosing the ABS module and find out why it's not responding to any of the other vehicle modules on the network or the scan tool. And then we're going to go ahead and go from there and do a CAN network test to see if the CAN network wires got melted or damaged in the lightning strike also. The one thing to remember is that there's no physical damage done to this vehicle from the lightning strike. There wasn't like a major harness malfunction or melting going on. It's basically all the static discharge to these sensitive modules and sensors that are they just got taken out by the lightning strike on there. So we're going to go after the ABS module, figure out why it's not responding, do a pinpoint test. It's long, it's invasive, but it's a good way to show that there are more than one power and ground coming to most of these modules. You have to realize that when you're going after these modules and finding out why they're not talking or working properly, and in order to condemn them, you need to know everything is coming in that should be coming in. Okay, so without further yakking, let's go ahead and start pinpoint testing the module to see if it's the module or the harness causing all these issues. I sure hope it's the harness, and I can just fix a wire or two, and we can get this thing back up and running, because that module is very, very expensive. We'll see. Let's go to it. Okay, I'm going to take you down to the engine compartment here. Now, what I like to do whenever I do any kind of work like this, where I'm doing pinout tests, is that connector is way down in there, and it's buried down in here. Back over in this area, back in here, and the harness comes down right here actually. So what I'm going to do is I disconnected a couple of the push pins on there. You can see them right here. They were hooking into the bracket and looping it around, and now I have it out in the open right here, and I can do a proper pinout test on here and get super accurate results that way instead of reaching down in there and trying to do it. Now, the reason for this is because there's a lot of different powers and grounds coming into the ABS module itself. They have dedicated high current fuses for the ABS pump on there, and then there's constant power for the ABS module, and then there's start and run power to wake it up on there, plus the positive and negative sides of the CAN bus network to be able to test. And you want to make sure you're doing it right before you condemn a module like this that's $500–600. So you can see on here, we have all the pinouts on here to test. I'm going to go ahead, go through them on the wiring diagram, and I'm going to highlight them, and that way we know exactly what to test and when to test it based on key position and stuff like that. Okay, we have our connector up here. We're all out in the open. We can do some good accurate testing. I have the connector pigtail all listed out here, and each one of the pins on here that I need to test highlighted, and of course the polarity marked on them so it's easy for reference when it's facing the same way as the connector on here instead of trying to read through the list on here. So what we're going to do is we're going to go after the ground first, which is this one right here, pin 16. We're going to make sure that's okay, and then we're going to use that from now on for our reference ground on here. So we got going into there, of course it's me a constant, and then I'm going to go over here to our positive terminal, and we have plenty of amperage driving that motor. So after that, we can start going to the other pins on here that are carrying voltage, the positive side. And we have two big pins down here that I believe are constant. Okay, no sweat. And then we have pin 4, which it appears I'm going to need an adapter for. Go down into pin 4 here. Was it 1, 2, 3? Third one in. Okay, so pin 4 should be in start and run. Let's go put the key to the run position. No sweat. Okay. So that one has plenty of power coming into it also. And there's one more, I believe. Positive. So that should be all of them, actually. We tested 1, 32, and 4. And all we have left is the grounds over here, which we already tested 16. This one right here, number 47, is a reference ground, which comes from the same location, but definitely needs that for the internal workings inside of there. So let's go ahead and test that with our constant powers. So like I said, everything coming into the module on here works just fine. Now at this point, the module's not responding. Only other thing it can really be is the CAN network itself being messed up on here. Like I said, crossed wire, shorted wire, stuff like that, or another module on a network that's bringing it down. So the easy way to go about that without even testing anything on here is to plug it back into there. Unplug the other high-speed network modules like the PCM and the cluster, which is easily accessible. Let's see if we can talk to this sucker. Okay, one final check before we button this back up on here. What we're going to do is we're going to test the positive and negative side of the high-speed CAN network with other points on the CAN network to make sure that there's continuity between the two of them. Now, the easiest way to do this and the best way to do this is to test from here to the DLC, where we're trying to actually talk to it. And you can see pin 6 and 14 on here. It's a positive and negative side on there. So I have the multimeter in the other side already. So what we're looking for is continuity on here. Okay, we have perfect continuity all the way to the DLC. Now let's make sure it can talk on the other side, which it really doesn't need on a CAN network. We're going to go plug it into the other side there. And it should go back to 0.4, 0.5. Okay, so with all the other modules connected in the high-speed network, this connector on here for the ABS module has continuity back to all of them. Right there, I can tell you right there. No shorts to power or ground, no issues at all. So when we connect this back up, we should be able to talk to the ABS module. We tested all the powers and grounds coming into it. Everything powers up when it should. So at that point, it's up to the module to power up and talk. So I'll plug this back in and see if we lose all communication again. And then, for heck of it, I'm going to disconnect the PCM and the cluster, and we're going to try to talk to it again. All right, let's plug the scan tool back in and see if we can talk to different modules on the network and see if we can talk to the PCM and ID the vehicle. So we're going to come over here, strap you down to the IDS, and turn the key on, see if we can talk to it. And I can already tell it's not going to be able to talk to it. Oh. Okay. Same things before. disconnect the instrument cluster, and I was able to talk to it. Now this is all with the ABS module connected. When it was disconnected yesterday and overnight, going over here talking to it like this brings it up right away, just like this, just like it's doing now. IDs the vehicle, no problem. So it's definitely taking down the high-speed network on there, and it has something to do with the cluster being the other end of the network and having that terminating resistor in there. Yeah, it's causing it to take it down. So let's do a network test and see who's who in the world of CAN networks in this vehicle. Okay, so of course the cluster is dead because it's disconnected. The GEM module is talking on a different network. I think it's an ISO network it's talking on. PCM, we can talk to it. GEM module, same thing, it's on a different network. Pass PCM and the restraint control module. So 4x4 is talking to us. I think it might be on a medium speed CAN network though. And the ABS, of course, is not talking at all. So let's do one more test where we disconnect the PCM and the cluster and just try to talk to the ABS module directly and see what the heck is going on here. So I'll go do that. Okay, PCM's disconnected, cluster is disconnected. Now, let's see if we can talk to the ABS module finally. Now, if we can't talk to the ABS module, right there it tells you the module is fried internally, causing the draw, causing the network to be taken down. Yeah, ABS is still not responding. And we checked the CAN network from the module over to the DLC here, and we also checked the powers and grounds coming into the module. So that module is toast and it's taking down the whole network on here. For the heck of it, I'll go disconnect the ABS module, reconnect all this other stuff, the PCM and the IC and all that, the cluster, and then I'll show you everything will come back. There it is. Everybody's talking. Only guy that's out of the party is the ABS module. That right there verifies this module is toast. Alright, we're going for a little test drive here to see how the cluster reacts as far as, you know, fuel gauge reading, RPM reading, temperature reading, and all that. I'm not expecting any kind of speed signal because the ABS module is disconnected, and of course when it's connected it's toast. We're also losing the odometer on here also, displaying the odometer because it's not talking to the ABS module. I can see in a scan tool that PCM has its own vehicle speed reading from the transmission OSS sensor. So it has that for shifting and all those kinds of calculations, but we got nothing in the cluster here to tell us how fast we're going. So if he doesn't put the money into an ABS module, there's absolutely no reason really to going further on this vehicle. And the ABS modules are only from Ford. It's hard to find. One's in the junkyard. I don't know what he's gonna do. That one ABS module is $500 by itself. Plus the fuel rail temp sensor, it's like over 100. The alternator's fried too. That's putting out 19.12 volts. Right now it's disconnected because the battery's fully charged and I can go for this ride, but that's another thing you have to replace. All three of those you have to replace for this vehicle to even think about being roadworthy. Not to mention all the rust in the rotors and stuff like that. So I'll put a list together and see what happens. I don't know. Maybe no happy ending to this one. Drives nice though, plenty of power. So I don't know what we're gonna do. Okay, things are pretty busy in the shop here, but I wanted to do an update on this vehicle, I finally was able to find an ABS module from the junkyard. I got it for about $70, shipped to my door with the HCU just in case I needed it. And I just plugged it in so I can program it. Got it all programmed, and everything is back to working order on here. Even the cluster is showing 0 now instead of just hanging there in the balance. I haven't driven it yet to make sure it reads speed, but it should now because it's programmed and it's responding, not throwing no errors, and the rest of the modules on the high-speed CAN network are also talking to each other all at the same time. So that one was definitely fried, causing all kinds of issues. As a matter of fact, all the modules on here are talking except for the PAM module, which it does not have. So we're fully functional at this point. I know there's a broken tone ring on the front, but I want to go drive it first and make sure we have our vehicle speed and there's no other codes in the cluster that come up. And then I can go ahead and change that sensor and go for another drive, make sure the speed sensors are all working for each wheel on here. But progress, finding that ABS sensor for $70 was the big key to getting this whole network on here back up and running. Okay, so that will conclude our diagnostic series on the Lightning Strike vehicle. Hopefully this was informative and it was a little bit different. You don't see this every day, obviously, being a Lightning Strike. So I figured it'd be interesting to bring you guys along for diagnosis, see how I approach it for something so weird as a lightning strike. Like I said before, usually when a lightning strike hits a vehicle, especially a direct hit, every module on the vehicle has to be replaced, and it gets very expensive real quick. I was able to do this whole job, parts and labor, for about $750. This guy walked out with a vehicle running afterwards instead of thousands of dollars at the dealer. So overall, a great success.